Okay, all right, everybody. Thanks for joining. Today we're going to be going over encryption. So first we're going to start with the one-time pad. This is considered to be the strongest form of encryption, and what it is just a set of random bytes. Today we're going to be representing pixels. Those are our bytes today. So the first thing to note about it is that the key is the same size as the data. So let me show you the code real quick. So all we're doing is really simple. We're just going to go through, it's a 48 by 48 image. And so we're going to go through this section right here, and we're going to generate and place random RGB values. Okay, so let's run that. Okay, so there we see our one-time pad, our key being generated. And we can see, as I said, it is just a set of random values. Okay, so what we're going to do with this is we're going to XOR the one-time pad, the key, and the original image, okay? And so the principle behind this is that if your key looks completely random, whenever you XOR it against the original, the encrypted version will also look completely random. So let me show you the code for that one just so you can see what it's going to be doing is, again, like I said, it's going to be taking pixel from over here, XORing it against pixel from over here. Here, let's run it so we can watch. Okay. So you can see it selecting, it selects this pixel and then compares it to this one, and it's XORing them. Okay. Let's go ahead and finish that up. And so we see our encrypted image being generated right in front of us, going from the one-time pad, using that and the original image to generate the encrypted version. Okay, so let's let that work real quick. Okay, and so now that we have our encrypted image, we can see completely random. You can't tell what it is. Again, if you XOR a random set of bytes against an original, the encrypted version is going to be a random set of bytes. Okay, and so now how do we decrypt this image? Okay, so you take the encrypted image and the key. You no longer need the original image. And so you take the encrypted image and the key. And so again, here, that's right here in this module, it takes the encrypted image and the key, and it XORs those against each other. So let's run through that. Okay, you see it selecting. And so it selects the cell from the encrypted image, and then it selects the cell from the one-time pad. Okay, you can see that selection. Now let's make this quick. All right, we see the decrypted image coming out looking exactly like the original. Okay. So again, as I said, a major drawback of the one-time pad is that the key itself is as large as the data. Okay, so after that, we're going to move on to, we're going to use smaller keys. Okay, so instead of generating 2300 individual pixels and using that as our key, we're going to do it in groups. Okay, so we're going to try 2 by 2. So each of these little blocks is a 4. Okay, so this is going to be now 1/4 of the size of the original encryption key. Okay, so again, it looks random. We encrypt it, and we're seeing random. We don't know what it is. It's just the image. Okay, and we can decrypt that, and there we go. We get the original image back. Okay, so let's try and do 4 by 4. We're going to shrink the pad again. This is now 1/16 of the original size. Okay, the encrypted image, still pretty unrecognizable. Don't know what it is. We're getting a little bit more of these little artifacts, random pixels looking slightly different. Okay, now let's try 6 by 6. Again, now this is 1/36 of the original size. Okay, let's run the encryption. All right, now here, we're starting to get a little something. We see the outline of the house right here and a little bit of the sun. Okay, let's get really lazy and let's do 24 by 24 block sizes. Okay, so this is just a 4 byte key. Let's encrypt that. Now our image comes through. We can make out everything. We see here's the land, the landscape, the house, the chimney, the window, the door, the sun. it's all perfectly right there. Again, we decrypt it, it comes out to the same image. And so what you're probably thinking, okay, I'm not going to use a one-time key that small. That's absurd. I'm going to stick to 6x6 where you can't really tell what's going on. And so, okay, I think that's a good idea, but at the same time, what if our image was compressed? What if our image was simpler? So in the current image, we see there's a lot of detail, okay, but now let's simplify it, right? All the color, they're just solid blocks now, right? Let's run the encryption again. Here we notice that we still see a lot, okay? We still see the house, we can kind of tell there's a chimney there, and we see the sun. But at the same time, because of the way that these blocks look, we can tell that these are all the same color, that nothing changed from this pixel to this pixel. Again, we can do the same down here. Nothing changed from here to here because we still have these original blocks. Again, we can decrypt it and you get back to the original image. Okay, so now we're probably thinking, okay, then how can I use a key that is both small and effective? I want to be able to send an encrypted image and not have to send a key that's the same size of the image. Okay, and so what we're going to do for that is we're going to use stream cipher. Okay, so what the stream cipher does is it takes the original image and it takes a password. Okay, it hashes that password and it uses the password as a seed. I'm going to show you what the code looks like there. And so here's the hashing algorithm. I didn't write this one. And then here we take the value given from the key and we use it to randomize our set of numbers. And so now every time here, when we call random numbers, they go based on the seed. Okay, and so I like to think of the seed as kind of like a text file. So imagine your computer has 1,000 text files on it, and each of those text files has 1,000 random characters. Okay, so when you tell your computer to use a certain seed, essentially you're telling it to use a specific text file. So we say use text file 348 to grab the random numbers. And what that allows us to do is that the next time we go into text file 348, we can ask to get 348. And so we know we're going to get the same set of random numbers. Okay, so again, here, that's what that does. And so every time that we call and ask for a random number, it goes based on that seed. Okay, so here it's encrypted based on the key. So again, here we're going to decrypt it with a different password, hello world. All right, let's decrypt that. Okay, and we see it's random. It doesn't come out to our original image. It's not what we want. We use the wrong password. All right, so now let's try to use the original password here. All right, again, strong hello world, and then let's decrypt that. And that is, what is that? That's Dr. Nielsen. So this is not the image that we wanted. Let's try a different encryption. Please not Dr. Nielsen this time. Thank you. All right, so let's encrypt that. So there we see getting encrypted using our passphrase as the seed. All right, and then let's decrypt it with the same password. And there we go. That's our original image. That's the Mona Lisa. That's what we wanted. All right. So as you can see, you're able to generate an encrypted image with a smaller key. Thank you for watching. I hope you learned something. I'll see y'all later.